Hi, I'm Louis Rosenberg, Chief Scientist of Unanimous AI, and today I'm going to be talking about large-scale group brainstorming using swarm intelligence and generative AI. This is a collaborative project between Unanimous AI and Carnegie Mellon, and I'm going to start off just asking a simple question, which is why brainstorm at scale? And the answer is pretty obvious when we look at large organizations. The average Fortune 1000 company has over 30,000 employees with product teams that have hundreds of members. And yet, what is the ideal size for a real-time meeting where you can brainstorm, prioritize, deliberate, forecast? It turns out the ideal size for a meeting is only 4 to 7 people. That's because you get a good amount of airtime per person, a low amount of wait time to respond to others. But as the group size increases, airtime goes down, wait time goes up, and above 12 people, it's really just a series of speeches. And above 20 people, it's just chaos. And so how do we solve this? And so today I'm going to talk about how we solve this, first by talking about the biology of swarm intelligence, which is nature's method for enabling really large groups to deliberate in real time and amplify their group intelligence. And a spoiler alert, it's not about collecting and aggregating data. It's about forming real-time systems. Then I'll talk about a technology called Conversational Swarm Intelligence, or sometimes hyperchat. And this combines the principle of swarm intelligence with the power of generative AI, and it enables conversational deliberation, thoughtful conversation at potentially unlimited scale, including for doing things like brainstorming in large groups. Then I'll talk about a platform called Thinkscape that enables conversational deliberation at scale, and I'll show that. And then I'll show how we implemented Thinkscape in a study, a brainstorming study where we had distributed groups of 75 people, and we asked them to brainstorm together in real time. 2 different cases, first in a standard chat room, a large-scale chat like in a Google Chat or Microsoft Teams or Discord, versus this conversational swarm intelligence architecture that's really a very different way of doing it. Okay, so let's go and talk about the biology of swarm intelligence. Again, nature's method for harnessing and amplifying the intelligence of large groups. What nature does not do is nature does not take surveys or polls or votes. There's no analyzing of big historical data sets in nature. What nature does is it forms systems, real-time systems with feedback loops that enable groups to deliberate and converge on optimal solutions. And by deliberate in something like a fish school, we're really talking about a dynamic tug of war among different perspectives that converges on solutions very, very efficiently. And those solutions maximize the group's conviction, and they enable the group to function in a very, very smart way. Biologists call it swarm intelligence, and it's a reason why birds flock in fish school and bees swarm. They make smarter decisions together than alone. And so let's look at a quick example of fish school. So dig into a fish school. It's nature's optimized large organization. There are thousands of members. Nobody's in charge. And yet they can make decisions so smoothly together that biologists refer to them as a superorganism. They can navigate the ocean making all of life's decisions, and they do it super fast. How do they do this? They have a special organ on the side of their body called a lateral line. It detects pressure and vibration changes in the water around them, and that allows them to basically keep track of the intentions of their neighbors. And so they end up in these small subgroups that are basically deliberating in a little tug of war of intention. But because all of the groups of neighbors overlap, information propagates through the full school, and it yields these smart, rapid decisions in real time. And so to make this clear, let's look at a fish school. Here's a fish school. Let's give it a decision it needs to make. 3 predators approaching from 3 different directions. You have this large organization. All the individuals have limited information. No individual has enough information to make an optimal decision. And in fact, most of the members have no information about the threats. There are 3 pockets of fish that are aware of different threats, There's a group of fish in the upper left. They see a predator, they deliberate with their neighbors, and they want to move down and to the right. Another group in the lower left, they deliberate, they want to move up and to the right. And then a group of fish up in the right, they can see a predator, they deliberate, they want to move down and to the left. Now these are small groups making decisions, small teams even, in a big organization. It's not a collective intelligence, it's not a large-scale deliberation, but because all of these groups overlap, neighboring groups, the information propagates through the system and it yields a rapid, effective decision. And so the question is, can we learn from this and do this in large groups of people? And can we use this to deliberate in large groups and brainstorm in large groups and forecast in large groups? And so let's look at a group of 250 people. You have a real-time deliberation, impossible in a group of 250 people, but nature would say, hey, let's break this up into small groups that are sized well for a real-time deliberation. So in humans, let's say groups of about 5 people. So we could break it up into 250 groups of 5 people. Great. Those are 250 or 50 different little conversations. Nature would say, well, if we can make those groups overlap, now information could propagate through the full system. And so we could do this. Overlapping groups, single system. It turns out this fails. And this fails because humans did not evolve like fish. In fact, we are really bad at being in more than one conversation at a time. There's a name for it. It's called the cocktail party problem, because if you're at a cocktail party and you're in a little conversation of people, and then there's something interesting going on in another little group right next to you, and your attention shifts to the other group, you immediately lose a focus on the group you're in. And if you try to pay attention to both, you will end up paying attention to neither. We humans are actually really good at tuning out the other conversations. We cannot be in multiple conversations at once. So this doesn't work, and this is why this problem has not been solved. We humans currently do not have a way to have large-scale group conversations or brainstorms or debates or forecasting, but we solved this. And we solved this by creating a special kind of artificial agent that's called a conversational surrogate agent. And we create this agent and we put one into every one of these little rooms. Now, it goes into each of these rooms, and the conversational surrogate agent has some simple things that it needs to do. First, it's observing the conversation in its room and identifying interesting insights, key insights that are coming up in that group. So it's observing insights. It's then tracking the sentiments and looking at what are the insights that are most important that are emerging in this room, and it's going to pass those insights on to the agents in other rooms. And then the agents in other rooms, when they get an insight from another agent, they express it conversationally in their own little group as natural dialogue. And so if you're in a group, you're talking with 4 or 5 people and one AI agent, and that AI agent is participating in the conversation. It's not making things up. It's not grabbing things off the internet. It is getting insights from other groups and expressing them into your group. And this weaves all of the conversations together into a single unified conversation. And this is what we call conversational swarm intelligence. And it enables deliberations among groups of potentially any size. And it amplifies their combined intelligence, which I will get into. And so now you can have thoughtful real-time conversation at any scale. And it turns out that this technology of conversational swarm intelligence beats Mother Nature. So Mother Nature fish schools can only pass information based on proximity, groups that are next to each other. But CSI technology can be designed to be in what we call hyperchat architecture, where information can pass between any group, and it's passed in optimal ways. So the agents are looking to share content that maximizes each group being challenged by ideas, perspectives, and reasonings from other groups. So you're optimizing the passing of information, the sharing of reasons and counter reasons in any direction, and it becomes this hyperchat structure. And so we built this into a cloud-based platform called Thinkscape that currently enables up to 400 people to come in and deliberate in real time. It's currently text chat, but we have voice chat and video chat versions that are in development. And this is what the text chat version looks like that we use for this study. Groups up to 400 people can log in from anywhere in the world. When they come into this platform, you can see, in this case, there's 110 people that have logged in. We can see who they are. They can either be named individuals or just be anonymous, have anonymous usernames. But they immediately see how they are broken up. These 110 people are broken up into 22 different little subgroups, each with 5 members or so. And that deliberation visualizer will show them in real time how information is passing, so they never forget that they're part of this big system. There's an area for groups to chat. There's an area where you can have voice to text, so people, if they don't want to type, they can just speak. And there's an area for sharing media, images, videos, spreadsheets, whatever. And then a question area. And so an example question, in this case, this is something we did for a group that was studying nuclear energy. And we said, what's the biggest concern about building new nuclear power plants in the United States and why? This is actually a brainstorm. We're asking a group of 110 people, what's the biggest concern and why? We ask that question, and the discussion starts. The question gets sent to all the people. It's telling them to express their opinions and to really give reasons and to respond to others. So they've got a good amount of description of what to do, and they have a time. And so now it starts, and and immediately the group is deliberating. You can see that the deliberation visualizer, AI agents are passing information between the groups as they're talking. This is sped up a little bit, but we're also in the moderator view. So it's 110 people. You really wouldn't watch the conversation in this view, but if you are the moderator, you can click on any one of these rooms and you can jump in and you can see, oh, here's the slow, thoughtful conversation that's happening in that room, and the system is tracking all of those rooms in parallel, identifying insights, extracting insights, agents passing information between. And then if you're the moderator, you can also click and get real-time insights so you can see the bird's eye view of what's happening globally. And so here, we're in the insights view. You can see the different toxic waste is emerging as the top idea based on sentiment. You can see it's extracting key verbatims from every room, so you can keep track of the key things being said. You can keep track of an ordered list of all the ideas so far. There's 11 different ideas that have come up, and you can look at the sentiment. And so the moderator can keep track in real time of this global conversation. And then when it's done, because it's been tracking all the ideas in real time, all the different rooms, all the back and forth, measuring the sentiment of every person, and determining the key arguments and counter arguments all in real time. The instant the 6 minutes were up, it gives you an answer, in which case it says the top brainstormed answer was toxic waste. And it gives the collective reasoning across 110 people. And so it says our collective perspective is that the largest concern about building nuclear power plants in the US is toxic waste. We consider the dangers of radioactive material, the long-lasting environmental and health impacts, and the challenges of safe storage and disposal. While some argue that waste is well contained and nuclear energy is sustainable, we concluded that the long-term risks are outweighed by these benefits. And so the nice thing about getting this summary in real time is that then if somebody's moderating, they can ask a follow-up question or many follow-up questions. So it can become an interactive discussion between a moderator and 100 people or 200 people or 400 people or potentially 4,000 people. The technology itself is scalable. And so we ran a formal study with groups of 75 people, a brainstorming study at Unanimous AI and Carnegie Mellon. We used something called an alternative use task, which is a task where it's kind of a standard brainstorming test where you give people common objects, give a group a common object, and you say, hey, can you come up with ideas for using this common object in some other way? And we said, we gave a scenario of you work for a company, you have thousands of surplus plungers? Can you come up with good uses for these plungers so we can sell them for things other than as plungers? And then we gave groups the time to brainstorm, and we did that for a number of different scenarios. And we did this in two ways. We had groups of 75 people brainstorm in this hyperchat CSI structure, or in just a single large group, a single large chat room like a Slack or Teams or Discord type of traditional chat. And then we asked them, after they brainstormed on different topics in different ways, which method they liked better across different metrics, to really get the sense of their experience. Did they experience this as a preferred way of brainstorming, or would they rather just brainstorm in one large group? And the results were really interesting. And so we saw statistically significant results where a significant majority of the individuals said that they felt it felt more productive to brainstorm in a small group and have insights get passed in from other groups. They said they felt more heard, which is also really interesting if you consider that in a big chat room, you say something and 75 other people potentially see it. And yet they felt more heard when they were having this thoughtful conversation with 4 or 5 other people and then having their insights get passed by AI agents to propagate through the full network. They said it felt more collaborative in the CSI method. They said it surfaced better answers. They said that they felt more buy-in in the process, which is also really interesting because they were more invested in the process when they could have this thoughtful deliberation. They felt more ownership in the outcomes, and they significantly preferred it overall. And so that's the study that we published, first about how the technology works, and then the fact that in testing it with large groups, people really do prefer this method, and they found it to not just be a better way to collaborate, but a way to really build buy-in and ownership across large groups. And so that's Conversational Swarm Intelligence. It's a large-scale method for conversational deliberation, which is useful for brainstorming, but also for discussion, evaluation, debate, problem-solving, forecasting. We've been conducting studies looking at, can groups prioritize more efficiently together? Can they forecast more accurately together? Can they debate more effectively together? And every time we look at it, we're really seeing very, very strong results. So thanks.